Hello again, and now let's see this last most important in-loop testing, which is vehicle in-loop testing. Let me elaborate to you what this vehicle in-loop testing means. Vehicle in-loop is an approach that fills the gap between software or hardware simulations and full road testing. Now, this is the most accurate testing or most nearest testing to full road testing. Common vehicle in loop testing include verifying features such as parking brake assist, lane changing, emergency braking, and evasive steerings, along with autonomous driving functions. Please understand that vehicle in loop testing is very complicated. Testers must design a simulation environment that faithfully replicates actual circumstances. Road markings, traffic, and signs are all part of the will environment. The test apparatus then exposes a real car to that simulated environment. In other words, testers drive the car on test track while the simulation provides the input for its sensors. Okay, so here the car is real, the vehicle is real, the driver is real, but the inputs are coming from simulation. This provides safe environment to perform dangerous and risky maneuvers requiring target vehicles without worry or a worry of inclusion. Using repeatable scenarios for edge case tuning. Okay, so tuning means tuning of the sensors, tuning of the fuel pump, tuning of the various calibration parameters. All these things are included in edge case tuning, reducing the cost of real target vehicle drivers by virtualizing them. Okay, so there may be some, we are putting some dummy vehicles, not the real target vehicles. So by virtualizing them, we are totally reducing the cost. And using in-vehicle automated test case, loading and real-time data post-processing to significantly reduce vehicle testing times by as much as 70%. So it is proved mathematically that using vehicle in loop reduces the testing time as much as 70%. I think this should give you a very comprehensive picture about the efficacy and the importance of vehicle in loop. Vehicle in loop creates a virtual risk for the car that the driver can see on augmented video display. Okay, for example, let me point out. You can see in this picture, which I'm just rounding off here. In this picture, you can see it is an augmented virtual reality, and a driver can see the augmented video reality. The car must then avoid these hazards by taking actual physical action on the test track. And the virtual dangers can examine the scenarios that are too complicated or risky to implement physical target equipment. For example, if you want to replicate a target car or a target truck on the actual road to avoid a collision, we cannot actually bring a actual truck or actual car and put it opposite to our ego car. It is too risky and too complicated. And moreover, it can cause severe injuries to the driver. So naturally, we use a virtual augmented testing, a virtual simulation reality, so that it can be tested safely. And let me elaborate by saying VIL, virtual vehicle in loop, is actually one of the last steps in testing process. In the early phases of software development, testers will often first use software in loop, which simulates the vehicle and its entire environment. This software-based simulations can run faster than real-time tests and effective in verifying multiple scenarios quickly. The next phase of testing is hardware in loop. Okay, I'm just what you call summarizing the whole what we have learned in chronological manner, in a chronological order. Next phase is hardware in loop, more complex process that uses physical test benches in a lab environment that send inputs from actual radars and cameras to an electronic unit. The next step is vehicle loop testing, which typically occurs on a closed test track using a real vehicle. A human driver sits behind the wheel, but the inputs that vehicle's ECU responds to are simulated. In other words, understand this very carefully. This sentence is of paramount importance. If you understand this, you understand vehicle in loop. A real driver sits behind the wheel, but inputs to that vehicle's ECU, response or simulated. Inputs are simulated, but actual human driver sits behind the wheel of an actual vehicle. In other words, the pedestrian carelessly stepping in front of the vehicle is not really there, but an ECU under test doesn't know that. The ECU will send a signal to apply the brakes, and testers can measure the effectiveness of the whole vehicle working as a system. Okay, so this paragraph is extremely important. You please go through this paragraph. If you can just pause the video and go through this paragraph, you will clearly understand what exactly this vehicle in loop testing means. I hope by now you got a picture, a clear idea. But if you understand this paragraph very clearly, then you have totally grasped the concept of vehicle in loop. And vehicle in loop has several benefits. By now you must have got a clear idea what this any of this in loop testing benefits are. It of course reduces the enables the testing of complex software without need to physically construct the test environment, which can be significant cost saver. So every in loop testing, every simulation is by default a cost saver. For example, without vehicle in loop, a test environment might require to use of a dummy to represent a pedestrian. Okay, I'm sure you must have seen in some YouTube videos a dummy pedestrian walking across the road and a vehicle stopping. Even the dummy cost is eliminated with the help of will or vehicle in loop. Vehicle in loop allows the enables repeatable testing of multiple scenarios in vehicle environment. The same pedestrian, whether he's walking or running across the road or walking across the road or he's jogging across the road, not only just a human pedestrian, it may be a deer. I'm sure everybody has seen some videos, suddenly a deer trying to cross the road and vehicle collides with the deer, or some kind of cow or donkey. Such things also can be replicated, and also at various speeds, and also at various scenarios. Is it the left side of the road, or is it the right side of the road, or is it the middle of the road when the colliding is happening? All these things can be simulated, and of course this much of simulation or this much of replication is not possible in real world. So this is one of the main advantage of vehicle in loop. And the vehicle in loop environment reduces the amount of time needed for vehicle test integration and for the use of test tracks and special test environments to verify functionality changes and feature enhancements during software development iterations. The vehicle in loop supports the qualification of a test to be ready for time consuming and extensive on-road vehicle test. Now this is self-explanatory. It supports the qualification of test to be ready for time consuming and extensive on-road vehicle test. I mean, we are not eliminating the on-road testing, but by the time this vehicle goes to on-road testing, we have already eliminated a maximum degree of risk. We have already eliminated a certain level of risk, and we are already going with for on-road testing with a certain level of confidence, thanks to VAL. Okay, hope you understand the benefits of the VAL. Thank you.